Hey everyone, this video here is catering to the 2011 free response questions. I'm gonna go over the scoring guidelines to give you a better idea of how everything was placed. But feel free to text, email me, or even meet up with me on Google Meet should you have any more questions after this. But I'm hoping that this video will kind of help guide you along the process. Just keep in mind that there are a lot of other good resources too. Whether it's the scoring guideline, Ask Mr. Calculus, or even just watching YouTube videos, okay? So just keep that in mind. Here we go. Number one. So this one here is a particle motion problem. I'll go straight through it. If you notice in number one, they're talking about if speed will increase or decrease. Remember, this is the example where I had a student and I was pushing the student in either in the same direction or the opposite direction. Remember that speed will always increase if your velocity and your acceleration shares the same sign. So notice here in part A, you have to check for velocity and for acceleration at that particular time. So what I'm thinking you guys would do is you would probably program V of t as y1 and a of t as y2. And then once you go to your home screen, you would just type y1 parentheses 5.5, which should give you about negative 0.4. And y sub 2, which represents acceleration at 5.5, which should be about negative 1.35-ish. Okay? The value here really doesn't matter. You're looking at the sign. Because they both share the same sign, they're being pushed in the same direction, you know that speed will increase, okay? But you have to have those two components, okay? Part B, they're asking you whether the average, what's the average velocity of the particle from 0 to 6? Basically, you're just integrating V from 0 to 6. But to make it an average, you include that fraction on the outside, the 1/6. This is a quick plug and chug. In this case, you would be integrating y1 from 0 to 6. You would be using the math9 function for integrals. A lot of people tend to forget the 1/6, so just keep that in mind there. Always make sure that you guys are rounding to 3 decimal places, okay? Part C. So part C, we need to find the total distance. So just remember, total distance, you're integrating speed, okay? You are integrating speed. So the only thing tricky here is how do you type that in a calculator, okay? So basically, you would go to math9 for the integral, okay? Then you would go to math to the right and then press 1. You should see ABS. That should pop out absolute values. And then you would just do alpha trace to plug in y1 here from 0 to 6. Again, this is a quick plug and chug. A very straightforward calculator problem that you should get the majority of the points from, okay? And here's the last one for 0 to 6 in part D. The particle changes direction exactly once. So remember, here we have to figure out when this particle changes directions, okay? So we know that the particle will change directions at a critical number, which is basically when your derivative, or in this case, when your velocity is 0. So what you guys would do here on your calculator is you would graph y1 in this case. You would graph it, you would fix your window where your x min should be 0, your x max should be 6. This next part is not needed, but optional for you guys. Sometimes it is needed. Your y min and max. Since we're looking for a 0, let's reduce our window for our y min and max to 1 and negative 1. So here, you should, once you hit graph, you should see the graph cut through the x-axis at one moment. From here, you would just calculate your zeros. So that's just second, trace, 0. You would pick a safe left bound, right bound, and it really doesn't matter if you guess, okay? But at the very bottom of your screen, if you did it correctly, it should say 0, and it should come out to about 5.196. But remember, we're not going to round it because it's not the final answer. So what we want to do is we want to find the position at this time. So there, if you want to consider where you start, that would be at time 0. So if you guys notice way back at the beginning, they mentioned that x of 0 equals 2. So what you do here is your integral has to start at that given condition. So if your given time was 5, then you would start at 5 here, okay? But in this case, since they gave us that at time 0, we're going to create our lower bound at 0. And we're going to go up to our b value, which is pretty much where that 0 was, okay? That was like roughly 5.19552. And again, we're keeping extra digits so that we don't lose the value of the problem. We're going to integrate here. So we're going to integrate v, but remember, that's just the accumulation. We have to consider what we started with. So in this case, it was x of 0, which we know is 2. Okay, so this is pretty much another plug and chug. You would just do 2 plus math 9 of y1 from 0 to either 5.19552, or you have the option of storing it if you remember how to store, okay? But this one here is pretty much straightforward, okay? But feel free to text me questions should you still have questions after this video, okay?